Hello. Oh, I forgot to turn on the light behind me. 1 second. There, that helps a little. Not a lot, a little. Hey, White Count Phil. Okay, today is the 14th of November 2018. My name is Jeff. I write code every day, and I usually stream it here on Twitch. This is the nybbles.io daily programming stream, at least that's what it originally was called. I try to keep that up. I am working on Basecode, and that is a programming language that I'm designing. It's a long road to the end, but making good progress, I think. So, okay. So yesterday I did get some of the type tagging stuff in place. I got most of the stuff from the lexer and the parser. I'm kind of testing some of that and trying to get some better error reporting, make sure that the approach I've got in the lexer for analyzing and categorizing it is decent. So actually, let's take a look at that. So what I did yesterday afternoon was I added a new token. That token is called a type tagged identifier. And then we just have our standard, somewhere, identifier. So really briefly, this is type tagged, right? And obviously if you didn't have that, that's just a regular identifier. Then in the, excuse me a second. In the lexer, what I did, so I took the existing identifier handler and I renamed it naked identifier, because that's what it is, right? And this was just the code that was already there. I just renamed the method. And then I added type tagged identifier. And so we'll go through this. What this does, again, it does the basics, right? Okay, is there an identifier? Yes, great. Then what we do is use the existing mechanism we already have in this to store the position of where we're at in the parsing stream. And then I defer a restore to that mark and then removing it from the stack. And then what I do is I read a character. This false means I'm critical of whitespace. So if there's whitespace here, then we're going to get a blank, and that's not what we're looking for. So if I read the next token and it's a less than, I go into this case, and this is like a little mini parser, except I'm not parsing to use any of the data here. I'm using it to categorize. So what I do is I go into a loop. I'm looking for an identifier, and then I read a character. So first, I'm looking for an identifier. So if I don't get one, then we're done. But if I do, then we read a character. If it's the closing bracket, then yes, we definitely, this is a series of types that are tagged. If it's a comma, or if it's not a comma. So if it's a closing brace, we're done, it's true. Otherwise, if it's a comma, we can continue. If it's not, then it's something else. So we break out. And then if it is in fact a tagged list of types, then we set the value and the token type, we return true. Otherwise, we fall through and we return false. Then what I did, because of the way my lexer works, it's triggered on the first character. So this is a multimap, and you can see in several cases, right, we have tokens that trigger on the same character, which is fine. That's the idea behind the multimap. So if we get to a W, right, that's the start state, and first we try to see if it's a while, because that's more specific, right? So we go from most specific typically to least specific. And if it's not a while, then we try to see if it's a with. If it's not a with, then it's something else. And typically for these constants, like while, with, tuple, transmute, the way the lexer works is it's looking at the token on the end of it, and if it's a space or if it's some other kind of character that we know doesn't align with what these are used for, then we don't consider it to be the reserved value. So some languages, they just reserve certain words completely. Sorry, that was me. Didn't want to cough. But in Basecode, I'm trying not to absolutely reserve. I'm trying to reserve things in context, right? So if it's in the context that it matches the reservation, then it is used that way. Otherwise, it's just considered normal. So anyway, for identifier, obviously, we have to trigger on any of the possible start characters. And I didn't want to like have 3 different scenarios for each one of these characters. That kind of gets crazy. So instead, what I did was I took the existing identifier method, and so the lexer goes to identifier, and then identifier tries both cases. In order to do that, I need to store the position of where we're starting, because what we're going to do is we're going to try the type tagged identifier first, and then we need to roll the position back to the beginning of that to try the naked identifier. So that whole set of changes is working, right? It's identifying these properly, it's passing in the correct tokens, that's all good stuff. And then on the parsing side, what I did, so if we look at the AST, I had symbol, that's what was being used for everything. Hey, Soding. Yeah, it's a macro. Let's see, common defer. So it's a whole bunch of C++ nonsense. Essentially what you get is you get a local type that has the block of code inside of it, and then I've got a macro that wraps that so you can kind of have some nice syntax. And it gets wrapped inside of this lambda expression. The thing about defer that I like is there are some cases like this, right, where if I was going to do RAII, I would have to wrap it, I'd have to make a type. So in a sense, at least in C++, the way that defer works, the way I've got it, it is using RAII to do it. It just is a little bit more of a flexible structure in the sense that every time you invoke the defer macro in the compiler, you get a new struct wrapper that has that little block of code in it. So it is still RAII, it's just, like I say, it's a different structure around it, and it allows you to arbitrarily put code in there without having to make a bunch of unique types yourself. It just does token pasting, right? So that it creates instances of that struct type for you. About as fancy as meta programming gets in, for me anyway, in C++. So then I added type tagged symbol and put that in the name map, and there is a type tagged symbol node, and that just creates the right node type for us. Excuse me. And then, let's see, I added type tagged symbol prefix parser. And then this goes into the prefix parse map. So I've got my instance. So it's just a singleton and it's in the map. So if we get a regular identifier from the lexer, then it goes to the standard symbol prefix parser. If we get a type tagged one, it goes to the type tagged symbol prefix parser. The type tagged one just calls create symbol, but instead of just returning that, which is what the normal one does, we know that there's type tagging next to it. So then we go into this little block, which slurps up that list of types, and away we go. So but what I wanted to do here is this, I just wrote this really quick yesterday. I wanted to make this a little bit more robust. So this is conditional. Excuse me. So I have a test case here I know this parses correctly. I'm going to just try a couple different syntactical variations on it with white spacing and missing things and all that, just to make sure that it kind of is giving me some reasonable error information if I mess it up. Because that's gonna, yeah. So that one's fine. So then, what is this doing? Loading you? Oh yeah, it's not doing anything. Which is fine. Okay, no worries. So if I put a comma here without another parameter, okay. Prefix parser. Oh, because maybe if I do, how can I do that? Well, morning, CM Griffin. Okay, so we're going to peek. If it isn't an identifier or a typed identifier, then we're confused. All right, let's try that. Hey, Zoding. I love that video that I saw you had put on Twitter, the clip from your stream about programmer documentation. The two sections. This is the part that everybody ignores. This is the part people cut and paste. I love that. It's great. It's doing the same thing. Time for a break. What's going on? Oh, no. Yeah, this is failing in a different way. Yeah, it is true. It's absolutely true. I will admit that there have been some times when I've done the cut and paste and then had to go back and read that section that everybody ignores after doing the cut and paste. Not too many times, but I have done it. Yeah, okay, so I know what the issue is here. The issue here is this is not getting categorized. So our categorizer, the lexer is actually very strict. And the lexer is saying, yeah, no, this isn't right. Like, this isn't what it should look like. So this must be something else. So actually, for now, I'm gonna let that one go. But let's put a valid, well, no, see that, the lexer's not going to identify that either because that's not an identifier. Interesting. Yeah. So we're just falling into the regular symbol scenario, I think. Yeah, so then the question is, do I want to relax the lexical analyzer a little bit to let that through. Yeah, so it's just not even falling into this case because it's not valid. But if I do this, actually let's do this, which this is not valid for range. I'm just using it as a convenient harness for testing. Huh, okay. Well, maybe I did find a bug. Yeah, it's not being categorized. Ooh, that's not good. All right. Why not? Okay, so the Lexer at least knows that it should try to categorize it. So but it's not an identifier. Why? Why is that not an identifier? That's why. Yeah, this is why I wanted to test it. Always get the head fake from the simple scenario that works. Okay. It's reading the space. Oh, all right. Well, so it's always skipping white space. By default, okay? And then, but here, we're saying no, we have to be on the identifier. So detect. Oh, yeah, no, I guess that makes sense. Duh. Silly, silly. So, yeah, I read an identifier, then I read a character saying skip white space because I don't care, like, at that point where these show up. If it's the terminator, we're done. If it's anything other than a comma, we're done. But now we're on, we've read past that character. And so we want to gobble up any white space. What does my main loop do? Yeah, okay, could do it that way. So we really don't care what this is. We just want to gobble up white space and then land on whatever the next valid token is. Hey Spoof. No, I'm not a dark theme person. People ask me that frequently. I'm sorry, guys. Like, to me, the dark theme seems like cargo culting. Like, everybody does it, and it's difficult for me to read. Maybe it's just because I'm old, but I do not like dark themed anything, right? Like, I've tried over the years to use them. I think they look like shit. I've just never understood the fascination with it. If it's good for you, great. But yeah, to me, that's one of those things, like, it's like everybody, it looks cool, but that's about as far, like, aesthetically, it's pleasing from a distance. I get that. But, like, I just really question its functional purpose. And anyway, yeah. So it feels like cargo culting to me. CM Griffing, it does feel like cargo culting. Valgrind does not work very well on OS 10. I have not tried it in months. Now I know that Sea Lion has, in these most recent builds, they've done some more integration with it, but I haven't tested it in a while. It's on my list of things to do, but yeah, I haven't tested it in a while. Apple has, in the past several iterations of their hardware and operating system, I hesitate to use the term locked down, but they have sort of kind of sandboxed certain things and made a few aspects of integrating with or interacting with the lowest levels of the Unix-ish kernel a little bit more complex, I guess. And so things like valgrind and GDB, like as far as I know, the latest versions of GDB do not work properly on OS 10 at all, for those reasons, right? Like there's the way in which those tools were written, they're assuming they can get to parts of the innards that Apple has deemed, you know, thou shalt not get access to, which, yeah, is kind of annoying. That's why when I debug for the very first time, it pops up that login, because I actually have to give rights to the process so that it can do some of the things that it's doing. Yeah, I don't know what the current state of valgrind is on OS 10. I think it's probably broken, but that's a guess. All right, so let's see what we got here. Yay, look at that. Yeah, okay, so that fixed that issue. So now we're in the right spot. All right. All right, yay. All right, so that works. Let's actually try a couple of different combinations. Do I have to use Xcode then? I mean, here's the thing, right? Do you have to use Xcode? No. All right, good, that worked. So let's actually just really briefly. Yeah, there we go. So you don't have to use Xcode, and I highly doubt Xcode's actually using valgrind. Apple has their own tools that are in that category, right? That they've blessed and all that. But if you really want to run valgrind against your code, do what I do. Create a Linux virtual machine, and then, you know, if you're writing C or C++, right, your code should compile, you know, with Clang and GCC minimally. So if I want to do that sort of stuff, I just switch over to Linux and do that sort of tooling in Linux where I know that it will function. And then when I'm done with that particular task, I come back to OS 10 and, you know, Bob's your uncle. Okay, so here's what we end up with. And this looks correct. So we have a procedure call with binding, and we have a type tag symbol, and that symbol is range. And then we have a type list, which is, you know, got 0, 1, 2, 3, 4. Yep. So good. All right, that part is looking all right. Now, yes, blessed. Now, yeah, I'm pretty sure that's gonna do what it was doing before. Whoa, kaboom. Ah, yeah, because we didn't get anything right. Huh. I'm noticing I've run into a couple spots here where my comma handling is, I didn't have null guards in some spots where I should have. So that's good. Those are being fixed. Oh, that reminds me, I don't know why. So there's a viewer, and he's on my Discord server. His handle is Supreme Vance. And I chatted with him yesterday, and he is looking for some help. Couple things. One, he is looking for someone to help him create some custom CSS animations, transitions for similar to like what you see from Streamlabs when people follow or subscribe or whatever. I technically could write the CSS, but I'm not an artist. I don't do animation that way. I mean, yeah. So if somebody is artistically inclined and they've done that sort of thing before, then maybe reach out to him for that. And also, he would like to create a custom Discord bot, and he's looking for somebody who knows Python. You know, maybe if you've written a bot before and you'd like to stretch your legs and do something a bit more yeah, there you go, exactly. That's about as far as I would go with it too. But if you've done that before, you would like to write a Discord bot, you know, again, reach out to him. He's looking for help in that category. So yeah. So when we redo this self-hosted, this is going to be one of the things that I'm going to want to try to think of to have a good way to do this. This is one of, believe it or not, one of the big challenges with parsers is error handling, right? It's tricky, right? Because there's different points in the process, and you have different bits of information, different amounts of context, and it's sometimes not easy to generate valid messages at every layer of the system. But so with that said, though, that is parsing properly, and I'm trying to think here. Yeah, actually, I think the lexer is pretty strict. It's gonna. So as an example, right, the lexer and the parser are gonna let this go because they have no way of knowing at that level that this is wrong, right? Like range does not support all these type parameters. It only supports one, and it has to be numeric, right? So that has to be asserted later. And that's fine, right? We do that with all sorts of stuff, but all right, so that's good. Those are fixed. What is the tool chain you use for network monitoring? So you have to be a little bit more specific. So I've used PRTG a lot in the past for what I would consider to be high-level network traffic monitoring. It works. I haven't used that in quite some time. It's been maybe 5 years since the last time I've been in an environment where I had to set something up like that. Nagios is a open source, well, they have a community version, but it's good and it's very popular. There's tons of plugins for it. My recollection is that there are, again, very similar high-level, bandwidth monitoring or network monitoring components within that. Excuse me. If you're talking about packets, if you want to do packet sniffing or protocol analyzing on a network, Wireshark is the go-to tool there. I've never been a huge fan of Wireshark. Their UI sucks, in my opinion, but it works. I mean, once you get used to it, it does what it's supposed to do. And I'm sure there are tons of tools in those categories respectively that are less popular that you might like better, and they may work just as well. So it just all depends on what you're looking for, what you're trying to do. But those, I think are the de facto standards that you're going to have most people tell you, oh yeah, use this. Again, the winner is not always the best. Yeah, but yeah. Again, like Wireshark, I think the issue, there's a lot of functionality in Wireshark. And it's just one of those things where legacy on the interface side had kind of accumulated before popularity set in. And then it was too late. Sorry, I got a cough again here. Man. So anyway, hopefully that answers your question. Okay, so we fixed a couple bugs. That's looking better. And we know that the AST is correct. My daughters, sir, they didn't like the Overlook Hotel. They tried to burn it down. Sorry, I watched The Shining last night. I don't know why. Every now and again, I'll pick some really old movie that I like and I'll rewatch it. That's the sign of a good movie. Like, I've seen The Shining so many times. I remember, I saw The Shining in the theaters when it came out. I remember the trailers. I was just young enough that, oh yeah, shinin, that's right. Oh, he's got the shinin. Groundskeeper Willie. But yeah, I remember when the trailer for The Shining came out. And that, I was just young enough, and no, I won't say how old I was, but I was old enough to see it, but young enough for it to impact me. And that trailer scared the shit out of me. I mean, it really did. And so did the movie. But I mean, I've watched that movie so many times, and no matter how many times I watch that movie, and I'm talking about the Stanley Kubrick, not the made-for-TV piece of shit they did. All right, can you guys hear me now? It's like that telephone yeah, was it? I don't know. There used to be these commercials. Can you hear me now? So which part of Colorado is Timberline Lodge in? Is it Vail or what part? I can never remember. So Voight Phil says, I would like to hear your opinion. Oh, it's in Oregon. Okay. So for some reason, I thought it was in Colorado. Maybe because the movie's supposed to be in Colorado. I would like to hear your opinion on error handling and parsers, more specifically on returning expected errors. We're looking at how your Bootstrap compiler distinguishes between failed parsings and syntax errors, and I don't really find my answer there. Let me give an example. I'm working on a SQL-like query language. Let's say a user tried writing this query, select func A, B, C, and the right paren is missing, okay? A good error message would be syntax error line 1, column 16, yeah. So the answer to that one is unfortunately tricky, right? So the way that I implemented this in the Bootstrap compiler, which is not necessarily the way I want to re-implement it when I do self-hosting, but the way I did this is this is going to be a little bit long-winded, sorry. I have 3 layers. So layer 1 is tokens. And I'm going to call it a token stream, okay? Layer 2 is the AST. So the token stream comes from the lexer, the AST comes from the parser, and then layer 3 is the code DOM, and that comes from the compiler translator. So let's talk about the 3 layers. So the lexer, what does the lexer do? So this text that we see here, this gets loaded into memory. There's a class that I have called sourcefile, which is just a wrapper around a file system file and the text. And the reason I have that abstraction is because I support, UTF-8, and so a lot of the UTF-8 nonsense is inside of that. But sourcefile knows the size, it keeps track of position. So as I say, hey, move to the next character, move to the next character, move to the next character, it keeps track of what line it's on approximately, and it keeps track of what column it's on for that line. So like the sourcefile class handles most of the positioning. So going to your syntax error line 1, column 16 sort of thing, right? So in my implementation, that's where that information is coming from. And the way that the lexer works is the lexer says to the file, hey, give me the next character, give me the next rune, and it does. And then from there, the lexer tries to categorize it. Right? What is this? And that's a trial and error process, right? So again, it uses the start character, and there's a bunch of different ways you can do this, right? But my approach was to use the start character for things and use that to try to narrow down to what type of token it is. So the lexer, as seen by the parser, is a stream. The parser just says to the lexer, give me the next token, give me the next token, give me the next token, give me the next token. Now the lexer does not understand really the grammar in large, right? Now, what I was just working on, that's an example of a mini grammar that it does understand. But in the large, right, the lexer does not know that, okay, if I saw this token, then this token should come next. That's the parser, right? So what happens is the lexer is going through the text in the source file and it's categorizing tokens. And then the parser is then taking the stream of tokens, and the stream comes left to right. Okay, so as an example, let's try to manually tokenize this. This would be an identifier. This would be a constant assignment operator. This would be a procedure call where the symbol of the procedure, okay, so actually let me back up. I'm getting ahead of myself. I'm at the wrong layer. This would be categorized as an identifier by the lexer. This would be categorized as a constant assignment. This would be a symbol. We'd get a left paren, a quote. We'd get, so actually this would show as one symbol or one token from the lexer. This is a literal string. We get a right paren, we'd get a semicolon. Okay, so then from the parser, what's happening? So that's the stream of tokens. Then the parser gets that stream. Now the approach that I'm using for parsing is known as Pratt parsing. And the reason I'm using Pratt parsers, so Pratt parsing is a combination of the Pratt approach and recursive descent parsing, right? So if you've ever written a standard recursive descent parser, you know that the big challenge with recursive descent parsing is handling expressions, right? So recursive descent on its own does not have a solution for things like, 5 times 2 plus y divided by 6, right? Okay, what's the ordering of this? What should be happening? Well, obviously, this takes the highest precedence. Then we would do the multiply. Then we would do the divide, right? And again, you can define your precedence orders however you want, but with recursive descent parsing, you have to kind of fashion your own solution to this. And there's shunting yard, and there's I think there's this thing called precedence tree or something. I forget what it's called exactly, but it's not shunting yard, but it's got some similar characteristics to it. Regardless, this sort of thing is tricky to do, right, with recursive descent. Now, Pratt parsers actually make that really, really easy. You don't need shunting yard, you don't need anything really super complex. So the way that the parser works is the parser has two tables actually. One, and everything is triggered by token in a Pratt parser. So the way the parsing layer works is if it is if we're starting from a clean expression parse, then it's looking for a prefix parser. If after that prefix parser there are related tokens in the precedence hierarchy. After that, then it will use infix parsers. So the way that you could think of this is prefix, infix, infix, prefix. So, and it would work the same way here. And right associativity and left associativity can be handled within, and like postfix and prefix and all that can be handled within infix parsers. Okay, so at this point we've talked about two layers. We've talked about the lexer, we get this token stream, and I've talked about the parser, and the parser is triggering these specialized cases for prefix and infix. And now we can stop there and then talk about errors, okay? So first, the lexer, what sort of errors can the lexer give us? Well, one, like if we're in the middle of maybe parsing a string literal and we get to the end of the file, right, before we get a closing quote, the lexer has enough context to do that. It can say, well, wait, I was trying to parse a string literal and it never finished, okay? There's a couple of cases like that, right? You could have like block comments where they never get closed. The lexer could error for those kinds of things. But really, by and large, unless the lexer gets a character it can't understand or it hits the end of file before it really expected to, the lexer can't give too many errors. So then it has to go to the parser. And so in your case, there's a missing parenthesis, okay? Well, that's grammar, and the parser is gonna enforce the rules that say, okay, I got these sequence of tokens and I'm expecting these other sequence of tokens, and if I don't get them, that's wrong. So in your example, and in my implementation approach, that sort of rule would be put into the parser, right? And the parser would recognize that a closing parenthesis is missing, it didn't show up in the stream, and it would report the error. But that's part of the grammar, and meaning that you have to build that into the parser on a case-by-case basis. There isn't anything automatic that does it, right? And then the distinction between whether or not the parser should raise the error, or in my case, like the compiler translator should raise the error, that all comes down again to context. Like, does the parser have enough information to really evaluate what it's doing? And see, I chose a very purposefully layered approach. So the lexer is dumb. It does one thing and it issues a stream of tokens. The parser is dumb. It does one thing and it issues AST nodes. And then as you go from left to right down the chain, you get to higher and higher context points in the pipeline. So for yours, again, it kind of depends on like how you've designed it, where you're keeping track of types and identifiers and things like that. But yeah, for simple syntactical grammatical errors though, the parser can do that, right? Which is, if we go back to type tagged, that's what I was trying to work on here, right? This is an example of when I say the parser is enforcing a grammatical structure. Here's an example of that, right? The parser knows, in this case, there should be a less than, there should be an identifier or a tagged identifier, there should be a comma or a greater than, right? Like it knows, and at this point, this is the beauty of Pratt parsing. When you get to this level, This is just standard recursive descent type parsing, right? And typically, like in Basecode right now, the parser only uses one look ahead. So I'm only ever looking ahead one token, and often I'm not even looking ahead, I'm just looking at the existing token that's in the stream. So it's not +1, it's just the current token. There are a couple cases where I think I look one token ahead. So the parser itself is, probably, LR1. The lexer is a bit more complex, right? The lexer does, and again, the term token gets way overloaded, but I'm going to use the word character for the lexer. The lexer does scan ahead quite a few characters to categorize tokens. And I consider tokens to be, they're not just individual characters, right? A token is potentially a grouping of characters that represent some meaning in the language in this case. So I don't know, that was a long ramble, but hopefully that was at least a little bit helpful. But it's tricky, right? Because sometimes, certain kinds of error cases are just really hard to get right. And so that's why I'm making some mental notes here so that when I go to rewrite this, I'm gonna definitely be taking a slightly different approach, I think. I haven't quite landed on which approach yet. And I've been reading lots of literature on different parsing approaches, different ways of automating parsing approaches. And so, yeah, that's all some really good stuff to come. But, okay, let's see. Mr. Anderson asked, the lexer goes by longest match, for example, int matches int plus garbage or an identifier. In my case, that would just be an error. It'd be an identifier, actually, technically. Let's verify that. Int, well, and actually int is not a, let's use U88, right? Because that's an example of something that's similar to a token that I have. But this would just be, U88 is just an identifier in my language, in my parser, because the way that I'm handling those special cases is I look at surrounding characters. So obviously, if there's another character after that that's a valid symbol character, then it's not the other one. Yeah, so that's basically what I'm saying, right? So here's an example. Let's talk about this type tagging, okay? The way that I'm doing this is range is an identifier, okay? And then if the less than is right next to the identifier, then it is a type tag. If there's whitespace here, then this is not a part of that, and it's something else. Then this is the relational less than, this is something I'm trying to compare to, and this is garbage. So in a lot of cases, it comes down to how things are, next to each other. For example, I can do, map foo, right? Well, map is a reserved word, but map next to this is not reserved. So the way the lexer works is it says, oh, it sees map, but then it says, oh, there's something else after it that I'm not expecting. Therefore, this must not be the reserved word map. Hopefully that makes sense. So it's the same thing with like tuple, tuple, right? Tuple, 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 right? These are 3 reserved words, but because the underscore is there tying them together, or if I did it this way, right, that's not reserved. So yeah, it's very, very greedy, I guess you could say. I've implemented it such that every token is as greedy as it possibly can. Yeah. Yeah, every token is lexed as strictly, I would say strictly, yeah, not greedy. It's very strict, yeah. There, and again, because I wrote this by hand, I didn't use a tool. I could be a little bit flexible in terms of if something was, is restrictive or not. Right, because I have to disambiguate between, in the case of the less than, greater than, unfortunately, right, these symbols, these characters are used for relational operators. So I have to have a way of disambiguating this from that, right? So it's just unfortunate, but that's how that gets disambiguated. And this is not, that's nothing, right? That's an error. That's not gonna parse right. Or it shouldn't. Maybe it will, and then I'll have a bug to fix. Yeah, no, it doesn't. This is meaningless, right? Like this is, almost a Boolean expression, right? So it's like range as a variable is less than something called S32, and this is garbage, right? So so there's just a couple spots in the syntax where, oh okay, yeah. Boy. Oh, because it doesn't exist. Duh. Of course. Makes sense. No, I know. I'm playing around with, I'm goofing with syntax here. This is not, yeah, okay. Yeah, it doesn't know what this is, which makes perfect sense. So, yeah. But anyway, you get the point. My personal site, I have that domain, but it's not, there's nothing there. It's on my list of things to do, but I never get around to it, so. Okay, couple things. Yeah, sure enough. Yes, the ever-growing list of things to do, exactly. And it is ever-growing. All right, so I think on the parsing side, I'm pretty satisfied it's robust. It's doing what I need to do. Now, let's talk about the compiler. So if I go to AST Evaluator, I have a symbol evaluator. So really briefly, the question is, do I want to just have both go through this one method, and because ultimately they're going to end up as a symbol element in the compiler model. So I guess let's start here. What is this going to be? I think this is going to be a type reference list T. Type params. Oh, so I did do some research finally on how I could set up my, so I have another laptop here what I'm going to do is I'm going to set up OBS and everything on that laptop, and I know how to get it to where I can just do a screen capture essentially through a capture card off my main laptop. So then all the OBS stuff will be in a separate machine when I stream, and then this laptop won't be constantly pegged at like 90% CPU. Because I do think that that's part of why the audio keeps dropping. I think some process is dying and restarting and under the covers. Did I try that? The answer is no. Question is, can I do that without breaking anything? Yeah, I'd have to stop the stream to change the frame rate. I could try that. I could try lowering it to 30, see if that makes a notable difference. I have one. I don't, it's just some cheap thing I got off Amazon. I don't even know what it is, but it just takes an HDMI input, and it's USB 3, I think, is on the other side. All right, so then the question is, do I want to make that const or no? How am I going to use that? Yeah. Okay, so on symbol element, so in the compiler model, this is the class that represents symbols. And what I've done is I've added a type reference list T, which is a standard vector of type reference pointer, to the symbol element, right? Because that's where all this stuff's coming from. These tag types, they're going to get stuck onto the symbol element. What is it complaining about? Nothing. Excuse me. Yeah. So we're going to refactor the evaluator function to take this tree. It should be really simple. We'll just loop over the list of AST nodes, which are just identifiers, which are type identifiers. We'll go look up those types and make type references, and that's it, you know. And then we'll have an array of type references, and then we'll have to refactor the parts of everything that are getting these type parameters, right? So on some of these other elements, or some of these other AST nodes, we had custom places for those. We can consolidate that down. And then things like cast, transmute, tuple, array, map. Then the question is, okay, so the way I'm doing that is I have all these special cases in the lexer, and I probably don't need that. So I think I can go through a loop where I kind of consolidate and collapse down, compress all this stuff into a more generic representation, which will be good because then as more of these cases come up, the plumbing to support them is all common, and I don't have to special case things everywhere. Then what we'll do, what that means then is that we have to assert certain, like for example, the map, key, key type of value type. We have to assert that there's two of those. Right now, the parser is doing that. And that probably ends up moving to the compiler, right? Meaning that the parser will just parse map and the associated type parameters to it. Then we get to the parser, we'll look at that and say, okay, well, I expected 2, and you gave me 6. That's not right. Or you gave me 1. So So actually this make symbol from node, that's where we can put the type parameter stuff. So really type reference is T, and then we can just pass that through. What I'm going to do, so on symbol node, on the left-hand side, we're going to put a type list node, and then on type tagged, we're going to do the same thing. That way, they're the same, and I mean, yes, we're going to end up with some empties, but that's okay, because then what that means is I don't have to check for null here. So I can just do a loop here. So we're going to do that next. So then the only other thing we have to do here so type tag symbols and symbols both go through the same evaluator. They just go through symbol, because symbol uses make symbol from node, which, because now I've got the AST is the same on both sides, I can just automatically loop through this list, and if there's something in it, we get type parameters. If there isn't, we get an empty list, and that's fine. Okay. Yeah. So by doing that, right, so we get this type list here on symbols, and it's empty. So yes, we're allocating an extra node and it's just sitting there, but again, I think it just makes things consistent and clean. And then in some cases, right, like here, we actually have stuff in there. And so, and if this is recursive, right, so if you have generic things that are being declared recursively, then they'll just appear recursively. So it's very good. Okay, let's run our tests. Oh, before I do that though, okay, this is okay. This is okay. And this is okay. Okay, good. So we're in the same spot we were in. Haven't broken anything yet. Okay, so let's take a look at come on, you can do it. All right, so we loop over the type nodes. We make a qualified name for it, because it's already a symbol, right? So we already have the plumbing to do that conversion. And type qualified name and scope. And that's so what we should do here is hey Raul Rita. It's going well. And as far as the parser is concerned, I have to finish this relatively sizable refactoring around the tagged type parameters for identifiers. And that's gonna probably impact a hefty amount of stuff. I think it's gonna end up being a lot smaller and cleaner, but yeah, I gotta go through that. And then I have to add lambda syntax and then some kind of switch, something or other. And yeah, some kind of switch. And then that's pretty much it on the parsing front. I mean, I want to make another pass, look at everything, think if I'm missing anything obvious, but for the most part, I think that will be all the syntax. There's a couple of notes and things I made for things. I got to go back, just make sure all those are cleaned up and there aren't any loose ends, but yeah, that's what we're looking at to finish the parser. So I don't know how many parts that ends up. Yes, there will be pattern matching in here, but the switch that I'm talking about is just kind of the lower level switch. All right, so let's walk through this. So I just hoisted this condition here. So scope is optional. So scope's passed in, we use that. Otherwise, we use whatever the current scope is on the scope stack. We turn the symbol that we're actually, so the root symbol, right? So it's confusing, lots of symbols. But we turn that into a qualified name. And so then even the question there is, can I just move that? Yeah. So we create an empty type reference list. we loop over any type, tag types that are on this identifier. And we convert those into qualified symbols. We look up the type. If we don't get a type, that's okay. We make an unknown type. And then finally, we push a type reference onto our vector, right, for that type. And yeah, so then I moved making the qualified symbol for the actual identifier down here. We make the actual symbol for the identifier, passing in the type parameters, and that's it. All right, it's only going to be symbol here. This is going to make this graph insane. So let's see how that works. We only have a couple of identifiers in our test file here, and one of them does have type parameter. So okay. Yeah, so that's support, print. Okay, here's range, and ooh, no type parameters. That's not good. Nothing. Okay. But it's only a symbol. Oh, am I running the same one? Yeah. Okay. What'd I do? I broke it. No. Oh, wait. Yeah. Crap. But it is. It is a type tag symbol. Sure thing, Voigtcom Phil. Have a good one. Oh, is that what's going on? So this is the procedure call node. The left-hand side is the binding information. Type, yeah, so that's going to be empty because we haven't gotten back to that. This has a symbol. Yeah, that's print. Okay, so this is a type tag symbol. This is range. Here's our type list. But what we're doing, yeah, okay. All right. I gotta really refactor this whole thing. But I think that was the issue. What the issue was, it was never, this code was not evaluating that node. It was kind of cheating. Okay, so now, but it's still a node, or still a symbol. Something's not right. Okay, here we go. Is this right now? Yay, okay, that's right. Yay, there we go. So now we have a type reference in here to S32. Perfect. All right, got that. So definitely here in procedure call, I can clean this up quite a bit, right? Because I can actually do a resolve or evaluate. We don't have to manually create the identifier reference here. Sometimes we may have to, but pretty often it should be there. But yeah. All right, I'm going to review what I've done today, and I have to wrap up. So I created a new test file just so I could isolate this tagged identifier stuff and kind of get it nailed down, both from a parsing and from a translating perspective. I think we're well on the way now on the translating side. Now I just need to go revisit all the things that are kind of using this construct and rework the translation for them. On the Lexer side, there was one bug in the type tagged identifier Lexer, and that was that we need to eat up any white space so that we're landing on the next valid token for a potential identifier. And in the parser, there were a couple bugs that I flushed out. One of them, or actually two of them, were around the handling for comma parsing. And it's just, I wasn't checking for null in some cases. So I added those checks in. I hoisted the type list node into the symbol node itself. So the AST builder just always ensures that that's a valid node there. I added a condition here to assert that we're getting the tokens we expect in sequence. Yeah, this was a case where we just needed to check for null. And then on symbol element, so then moving over to the compiler side, our symbol now can potentially have a list of type references associated to it. And so I added a type reference list T field and a accessor, and then we pass that through in the constructor. We set that, and then we just return the reference to that field. In element builder, so make symbol now takes an optional type reference list T reference, and by default it's empty, and that's fine. In some cases, a lot of cases, it will be empty. Then I enhanced make symbol from node, right? So we get the symbol node in. It potentially has this list of other types that are associated to it. And so this goes through and looks those up, gets the references for us, and then we pass that through and we create it. And then down here, this is like the base make symbol. You pass in the type reference list T reference, and then it just passes that through the constructor. In code down formatter, so for a symbol now, technically there can be edges between the symbol and type references. So I put that in there. And then in AST evaluator, type tag symbol just vectors through the symbol evaluator and oops. And the really the symbol evaluator didn't change at all, but procedure call I had to change a little bit, and there's more of the refactoring that has to happen here. But I was cheating before. I was creating the qualified symbol T struct. I wasn't actually creating, I wasn't evaluating the symbol for the procedure call. And yeah, I don't know, I gotta think about that. But yeah, anyway, for now, it's creating a symbol and it's processing all those parts and like it should be. And so that works. And then in AST, like I said, symbol node and type tag symbol node, they have that type list node on the left-hand side. That just makes things consistent. I'm just going to run the test real quick, make sure I didn't break anything too major. All right. This is okay. And this is okay. Yep. These are known error conditions, so. All right, I'm gonna push that up. And that will do it for me today. Thanks everybody for dropping by, I appreciate it. And I believe, should be online tomorrow. Same bat time, same bat channel. And till then, have a good one. Talk to you, bye.